Dear learners, in this session we are going to learn the clustering concept as a part of unsupervised machine learning algorithm through Knime analytic platform ensuring zero coding. Clustering. Clustering, it comes as a part of unsupervised learning. So here to perform this operation, we may require a large data set, but labeling is not essential for this operation. So we can have an unstructured data set for performing this clustering operation. So this clustering, in a small sense, it helps us to detect various patterns. For example, it helps us in grouping your emails, or it helps us in refining the search result. It also finds its applications in customer shopping patterns, to identifying the customer's shopping patterns by clustering all the customer who's having the similar shopping patterns. It helps us in clustering or grouping together, and even it helps in identifying the regions of images. Okay, so in the particular location you could cluster the images of a similar locations. Okay, in the other way, we can say that this clustering is much useful whenever you does not know what exactly you're looking for. So when you like to gather some huge collection of informations, we can go for this clustering. So here I just brought a small example pattern. So it's a collections of a clustering of 2D pattern. So here it helps in gathering. It helps in gathering the similar points, data points. So data points of similar patterns is grouped here. So again, this is an example of clustering. So as a part of clustering, we are going to have a k-means clustering algorithm here. So k-means clustering is an iterative clustering algorithm. Okay. So as an initialization, we are going to pick a k random points as a cluster center. So if the k can be any integer number, it can be k equal to 2 or 3 or 4. So based on that, the number of clusters could be formed. Okay. Then we are going to assign the data points to closest to the cluster center. Then the algorithm is an iterative algorithm. We keep on change the cluster center to the average of its assigned point. Okay. So once it creates a clustering like this, okay, so it stops when no points assignments has been changed. Okay. So when there is no more points for further assignment, it stops its process. So it is an iterative process. We are going to identify the number of clusters by k. So k indicates the number of points that is going to be formed as a cluster here, and we are going to perform an iterative collection of data, so grouping together. So as a glimpse, it's a k-means clustering algorithm. First, it allows the user to specify the target number of cluster, that is the k. So here we are going to first identify the number of cluster, then randomly this cluster centers will be placed. Then for each data point, we are going to attach, it is going to get attached to the nearest cluster center. So all grouping will be happen in these point, in the data point and the center point. So for each center, it's going to find the centroid of all the data points attached to it. So this is the basic functionality behind this clustering, k-means clustering. For each data point, it is going to first attach the nearest cluster center. Then for each center, it is going to find the centroid of all the data points attached to it. Then it turns the centroids into the cluster center. That's it. So that it's going to turn the centroids to the cluster center. Then it is going to repeat, and since it's an iterative process, it is going to repeat until the sum of all the data points distance to the center is minimized, or else there is no data for the clustering. So this is the just overview of k-means clustering algorithm. So here we are going to perform a Centroid-based k-means clustering algorithm. So we are going to classify, we are going to group your data set in forms of creating a cluster of similar patterns. So this is what we are going to perform in today's session. For that, we are going to take an iris dataset. So iris is a plant which has three classifications like setosa, iris versicolor, and iris virginica. So this is the three patterns we are going to have it, and we are going to classify this now. So based on the sepal length and the sepal width, petal length and petal width, based on this four criteria, sepal length and sepal width and petal length and petal width, we are going to classify these data set of three classifications, whether it belongs to setosa or versicolor or virginica. So all these three classes has 50-50 samples of data. So altogether this iris data set is going to have 150 data set, 150 rows or samples. Okay, so each of 50 of three classification, it does has three classifications of flowers like setosa, versicolor and virginica of 50 rows each. Okay, so we are going to this is our objective of today's learning. We are going to classify, or we are going to cluster the iris plant of three classifications. Setosa, we are going to cluster as a setosa cluster or versicolor clusters or virginica clusters based on the sepal length, sepal width, petal length and petal width. This will be the objective of today's learning through K-means algorithm, the clustering through K-means algorithm. So as I discussed earlier, this flower has different sepals and petal shapes. So I have brought this for your better understanding. This is, as I said, it is iris setosa, iris versicolor and iris virginica. Okay, so this is what we are going to identify whether this particular sepal length and petal length will belong to setosa, versicolor or virginica. So this is our it's called today's task. So same thing, we are going to concentrate on all these four parameters. Accordingly, we are going to classify its class as well. Okay, so this is the objective. For that, we are going to collect the data set. You can take the data set from the Knime platform itself. Else, when you Google for the iris data set, you could get this iris data set. So you can select, you can download that, or if it is available in the Knime platform, you can open it and you just save it in your local drive. So you just copy this iris.table from this location and paste it in your local disk. Okay, so wherever you are going to perform this operation, you just locally place it in your D drive or E drive. So iris.table. So this will be the complete flow of today's learning. We are going to create a flow with a data set, followed we are going to partition it. Since it is a machine learning concept, we are going to have a trained data set and a test data set. Through this partitioning, we are going to perform this training and setting, segregation of training and setting data set will happen here. Then by means of K-means node, we are going to perform this clustering. Okay, so then the cloud output of the clustering can be visualized in two ways. That is the test data set output could be visualized, as well as the trained data set output could also be visualized. So for visualization, we are planning to include this color manager in order to identify the cluster classification of different colors, and shape manager to identify the three colors of different shapes, and finally we are going to do it, we are going to visualize using this scatter plot. In order to identify the test data assignment, we are going to use this cluster assigner, and we are going to visualize again through the scatter plot. So this will be the complete flow. So just repeat, I am going to have a table reader. The table reader, you could get it directly just dragging and placing your data set into the flow. You will get this table reader, followed by partitioning. Then we have a K-means node. Then we are having visualization. Inside the visualization, we are going to have color manager, shape manager and the scatter plot, followed by cluster assigner and scatter plot again to visualize your output. So table reader, as I discussed, you can directly drag this table from your local drive and you can place it in the flow. Okay, so automatically this table reader will be open. You just click OK. So just click OK now. So you could see the table. So it has 150 row. So 3 classification, 3 each set has 50 samples. Through 3 into 50, 150 rows will be there, and the classes can be iris, setosa, and virginica or versicolor. So any of these three will be the class. So we are going to cluster this. This will be the objective now. So it contains the sepal length, sepal width, petal length, and petal width. So this is the 4 classification criteria which help us for clustering here. So next, insert this partitioning node. So identify in the node repository, as we discussed in our earlier video or earlier session, we learned what is it's all about partitioning. So same partitioning node we are going to insert it. So drag and place this partitioning node and then right click to configure here. So then again we are going to configure what percentage we are going to take it for the training data set and the test data set. So here I have taken 90 to 95, or you can take it 80% as well. Then you have to select whether you are going to take from the top 10 or you are going to do a random selection. So as I discussed earlier, random selection will give more efficient output. So we are going for draw randomly. Then just click OK. So it's if you if you make any changes, then it will ask you whether this will be resetted and it will be connected to all nodes. Just give OK. Then right click it, execute and open view. So there was an option like execute and open view. If execute and open view is not visualized, you can click execute. Then you can click the first partitioning and the last partitioning. So the first partition will show the training data set. So your first partitioning will give the training data set, and second partitioning will give the remaining test data set. So this is the first partitioning data set. So out of 150 data set, 120 is considered for the first partitioning, and for the second partitioning remaining 30 is considered. As I said, the data set contains 150 samples of data. So this is the table for the second partitioning. Then you can go and search it in the node repository, the k-means node. So k underscore means is the node name. So you can search it for k underscore means node. So you can drag it and place it in the flow. Then you have to connect it. You have to connect this first input node, that is output node of your partitioning, to the input node of your k-means. So first it allows us to identify the number of clusters. So how many clusters we need, since this classification is going to have 3 clusters, like classifications of 3 iris plant classification, like Centosa, versicolor and virginica. So we are going to have 3 cluster here. So number of cluster here we are going to take it as 3. So you just take this number of clusters is equal to 3 here, and you can take whether you are going to have a centroid with first k rows, or you can make a random initialization. So it is up to our decision. You can make it. Then the columns selection is very important. Which are the 4 columns which is going to help for this classification? As I discussed earlier, these are the 4 columns: sepal length, sepal width, and petal length and petal width. These are the 4 columns which is going to help us for this classification. So you just include all this 4 parameter into Word, then click OK. So cluster, we are going to coin the cluster. Then by default it will be centralized with first k rows. You can go with this, else you can go for random initialization. Then you are supposed to include your row values. Okay, so sorry, the column values. Then you can give OK. So here the number of clusters is 3, first row, and all the 4s has been given here. This is the configuration window. Then execute, right click again and execute and open view here. So you go to see this clusters. It has this classifications of 3 clusters: cluster 0, cluster 1 and cluster 2, cluster underscore 0, cluster underscore 1 and cluster underscore 2. So this is the cluster view. You can select either of this labeled input or cluster view or cluster model, whichever thing you can select. Want to visualize, you can visualize it. So if it is a labeled input, you select this labeled input, then you could see this cluster 0, cluster 1 and cluster 2. So these are the classification details about all this 3 clusters. So this is PMML cluster models, which gives a complete structure of your classification. So the dataset complete structure could be visualized here. So this is the labeled input. As I discussed, it gives the complete structure of your clusters. So next we are going to visualize this scatter plot. To visualize this scatter plot, we need this colors. We need to set this color of 3 different clusters. I just selected for red, blue and green, and have just changed the shape as well. So this is a diamond, circle and then your square. So like that, this is your visualization part. So visualization part. So next we are going to visualize it. So through this color manager and shape manager and scatter plot, we are going to visualize the output of the k-means cluster. So color manager will help us to identify or to assign the colors for the clustering concept, and shape manager will help us to assign shapes for the cluster, and finally that could be visualized using scatter plot. So color manager, right click and configure. So automatically the 3 classifications like Setosa, Versicolor and Virginica, these classes will be popped out. So here you can select this so you can select your column. So what column you would like to classify. Okay, so you can select your column here. Since we are going to classify for the class, so I just selected for the class. So then you can change the color appropriately by selecting every column name, and then you can change the color as well. So by changing the colors, you can map your colors, required colors to your scatter plot. Then click OK. So next is shape manager. So drag, identify the shape manager node in the node repository, drag it and place it here. Then right click it and configure here. Again, you can select your column name here. So again, I am going to select the nominal column as a cluster. So all these 3 cluster 0, cluster 1 and cluster 2, I am going to assign the shape for it. So for first one, I'm going to assign rectangle, then circle or triangle. So whatever shape you like to have it, you can assign the appropriate shape for your cluster. So the various shapes available are rectangle, circle, triangle, reverse triangle, diamond, hashtag, plus the cross symbol and then your X symbol. Okay, so these are the various symbols you can assign for your cluster. Then click OK. Next is your scatter plot. So you can right click it and you can configure here. So as I said, this might the classifications required, and this is a cluster point. If you want to change a background color, you can select this you can click this background color and you can select your color, whatever color you require. So here I have selected this dark color, so the output will be visualized here. So this is one form of cluster, and this is the other form. The green will be the other form of cluster and the blue will be the other form of cluster. So this is the output of your scatter plot. To visualize your test data set, the next part of the clustering, you can search for the node called cluster assigner. So take this cluster assigner, and the last part of your k-means output, the last node of your output, you just connect to the input node of the cluster assigner. Then you can select the other part is your test. So this part you are going to give it for your training data set, and this test data set, the 20% or the 15% of this will you are going to assign it to this cluster assigner. Then you can right click it and configure it, and then you can execute it, and you could see this cluster assigner table. So you could see this for 30%, that is for 30 rows, this has been classified. That is for test data, it has been classified. So to visualize the output, you can again drag and place a scatter plot, configure it, again execute it. So you could see this output as well. So thank you so much. We'll see a small demo now. So we'll have a demo. So as I said, you can select your table. So iris dots table here, you drag it and then you place it here. You drag your iris table and place it in the flow. So automatically you could see this table reader will be pushed into the flow. So automatically the location of this also will be visualized. Then you can click OK. Since I have done 2 times, you can delete one. Okay. So then you can right click it. You want to if you execute, you will see this output as usual. So read the table. While reading the table, we could see there is 150 columns on 150 rows, followed with the sepal length, sepal width, petal length, and petal width of the columns, and the class is the other column. So then now we are supposed to, I'm just deleting it since I have already done this. Delete it. Then go to node repository. So you just go to the node repository panel, then search for partitioning. Search for partitioning. So partitioning node will be there. You drag it and place it, and then you just right click and configure it. So here it will show the absolute, what is the relative percentage you are going to have, 80% or 90%. Okay, so I'll go with 90%, and I'm going to select this draw randomly, then click OK. So give OK, then again right click and execute. So after execution is over, again right click. You can see this first partitioning and the second partitioning. So now again search it in the node repository. K means K underscore, so K hyphen means K hyphen means you drag it and then you just place it here. Okay, so now right click it and configure it. So it asks for the number of clusters. So here I'm going to have 3 clusters, and I'm going to make the centroid as a first row. Then all the 4 sepal length, sepal width, petal length, and petal width I included here. The number of iterations you can make it here. Even you can make it as 99 or 100. So any values you can give it here. Then give OK. Again right click and execute and open view. So this cluster 0, cluster 1 and cluster 2 has been classified here. So 3 clusters has been framed. So now you can see the labeled input here. So this is the labeled input table with all the 3 classifications along with the cluster. Previously we have seen a column along till classes. Now we could see a column along with the cluster as well. So classification of cluster is done. Then you could see the cluster here. So cluster 0, cluster 1 and cluster 2. So this is the sample length of these values associated with it. So here we classified as cluster 0, cluster 1 and cluster 2. So then to visualize it, drag it and identify the color manager, drag it and place the color manager, right click it and configure again. So here you could select the class column name. So I am going to select this class here. Automatically these three colors has come. If you want to change a color, you change the color as well. So I go to scratches and then I'll change with colors like this. Okay, then give OK. So color is over. Then again right click it, execute it. Then again right click. You can see a table with the colors. The table with the colors of clusters 3, cluster 2, cluster 1 and cluster 0 all has been classified with the corresponding colors. Then shape manager, right click, identify in the drag node repository, drag it and place the shape manager, right click and configure here. You could select the shape name. First you have to identify the class, whether you are going to do it for class or the cluster. So here I am planning to have it for cluster, so have it for cluster here. Then all three clusters will be identified. You can change the shape as well. So I'm going to make it as asterisk, so a circle and a triangle. Then give OK. Then drag and place a scatter plot. Scatter plot we have done for many experiments. Again configure here. Okay. So number of rows, let it be the default. Give OK. Okay. Now execute it. Execute and open view. So you could see asterisk of this color and dark green here. So here if I like to change the background of yellow, I can change the color background, then I can visualize this. So this is the three clusters, the red color, green color and the blue color of three classifications of your iris plant. So if you want to visualize the test data, so as I said earlier, take the second partitioning and connect it to the cluster assigner and search for the cluster assigner node in the node repository. Then this perform for the under k-means, you just select the last output node to the cluster assigner. So here no configuration is required. So by default you can click it's called allow as it is. Then connect the output to the scatter plot. Again here also you can make the color manager and shape manager, and then you can include the scatter plot to configure here. Okay, so just execute and open view. Again this is done. Thank you so much for your learning. So if we learned k-means clustering algorithm, it's an unsupervised learning with zero coding. We have done this clustering of three classifications for this iris plant through this Knime analytic platform. Thank you so much.